Imagine being deep in the Colorado Rockies, where American engineers are pulling off a rare feat, raising a 70-year-old dam by another 40 meters. It's not as simple as just building something new. Out here, engineers are facing the massive task of placing nearly 611,000 cubic meters of roller-compacted concrete, RCC, onto an old structure. They're basically forcing two generations of concrete, separated by almost a century, to work together as one solid block. This isn't just a $690 million reservoir expansion. It's a rare chance to see a gravity dam literally transformed into an arch dam. So, how exactly are American engineers conquering the Gross Reservoir expansion? Stay tuned to discover the secrets behind it. And don't forget to hit like and subscribe if you're into these kinds of fascinating projects. First off, we need to realize that building a 143-meter-high concrete dam in the year 2025 is a massive challenge on many levels. By any global standard, this is a monster project, but it's absolutely necessary to secure a safe future for the area around the Gross Reservoir. Because over the years, water-related disasters here have been getting more and more serious. When water becomes critically scarce, vegetation and soil dry out completely, turning everything into a massive tinderbox ready to ignite. A prime example is the most horrific fire in state history in late December 2021. It torched over 2,500 hectares of forest and hundreds of homes in just a single day. So the Gross Reservoir expansion isn't just a technical upgrade, it's a mission to protect the lives of 1.5 million people. Because of its vital role, the original dam was actually designed to be raised later on. However, this time, the scale is massive. They're tripling the storage capacity. That means the dam isn't just hitting 143 meters in height, it's stretching to nearly 622 meters in width. To get it done, engineers first needed to drill deep holes into the rock on both sides of the dam and along the canyon walls, then set explosives to blast away the stone. The old concrete base also had to be cleared out before the new foundation could go in. Even after all these years, that concrete is still incredibly tough, so workers used a method called hydro-demolition. They hit it with ultra-high-pressure water, about 138 megapascals, 20,000 pounds per square inch, to strip away a 5 to 8 centimeter layer from the existing rock and concrete surfaces. This hydro-demolition was performed over a massive area, about 18,500 square meters. This process creates a rough, clean surface so the new concrete can really grab hold when it's poured later. For any uneven surfaces caused by small hollows, they pour dental concrete, and for weaker rock areas, they use foundation concrete. Since the dam is so vast, they had to lay down over 20,600 cubic meters of base concrete. To make it even more secure, workers drilled deep into the bedrock and pumped grout into every tiny crack and fissure. Right after the prep work, the material staging area becomes critical. One of the smartest things about this project is that all the raw materials are sourced right on site. This project gets all its rock from a quarry just south of the reservoir, which slashes costs and keeps heavy trucks off local roads. Statistically, they've pulled 2 million tons of rock from the quarry, plus another 1 million tons of debris salvaged from the blasting work to expand the dam. All of this material is used right on site to create concrete at the batch plants built on top of the dam. RCC construction on site. Every day, about 2,300 cubic meters of concrete are produced and moved to the base of the dam by a conveyor system so crews can build the main body. Before that, they use specialized formwork to shape each step of the new dam. This formwork consists of heavy-duty steel frames and special panels designed to hold the shape of the steps and the outer face during pouring and compaction. Next, the roller compacted concrete, RCC, is placed and packed. The RCC mix, which has almost zero slump and doesn't flow, is spread into layers about 30 centimeters thick by dozers, following the exact height and profile of the forms. Once it's spread, an 18-ton vibratory roller runs over the surface. This squeezes out air pockets and packs the aggregate and mortar to the design density. For a mix with the right consistency, about 4 to 6 passes with the roller is enough to hit high density. After that, a static roller can be used to finish the surface. This packing process has to start within 15 minutes of the pour and before the mix begins to set. Otherwise, you risk cold joints or weak spots between layers. Because RCC sets fast and needs specific temperatures, they pour non-stop during the construction season, from May until early winter, and pause when it gets too cold to guarantee quality. Each RCC step is about 1.2 meters high, stepping back about 0.6 meters from the one below it. This creates 118 concrete steps climbing up the old dam face. At this point, you could almost imagine that American engineers are building a 143-meter-high pyramid rather than a water reservoir. Once the RCC layers are finished, engineers pour conventional concrete for the outer face of each step. This stuff has more cement and higher strength than the RCC. About 68,800 cubic meters of it are used to stand up to the brutal snow and ice at Colorado's 2,100-meter altitude. To ensure the project's success, managing the construction is a massive puzzle because of the tight, high terrain and the many technical activities happening at once. To make the most of the short mountain season, the site runs almost 24/7 throughout the main construction months, maximizing the time for pouring and packing concrete before the cold weather hits. The Gross Reservoir expansion is a game-changer for long-term water security in Colorado, serving over 1.5 million people in the Denver area. Raising the dam by 40 meters will nearly triple the capacity, going from about 52 million cubic meters to over 146 million cubic meters. This expansion means they can hold on to more water during the snowmelt and spring runoff, instead of letting it flow out of the state when other reservoirs are full. Plus, it balances the storage between Denver's north and south systems, making the whole region much more resilient to droughts, floods, and climate change. By 2025, the new RCC structure has already reached the height of the old dam, over 2,100 meters above sea level. What do you guys think of this pyramid in the Rockies? Will it hold up against the pressure of billions of liters of water every year? Drop a comment below and let's get a discussion going. Don't forget to hit like and subscribe to support us for the next video.